Hey guys, welcome back to another lecture video for Chem 104. We're going to go ahead and continue our discussion of naming hydrocarbons. In this lecture video, we are going to learn how to name cycloalkanes with substituents. So let's go ahead and get started. So when you guys are naming cycloalkanes with substituents, the rules, they don't change too much. We're just going to fine tune them to make sure it's representative of the way that we're supposed to name cycloalkanes and not regular chained alkanes. And so the first step, just like all steps that we've kind of done in previous examples, is to identify the parent chain and name the parent chain based on the longest carbon chain within that structure. And so the only thing that's changing is how we're going to name these substituents. And I've kind of broken it down for you guys in terms of like a flow chart. And so let's just say that you're trying to name the substituent of a cycloalkane and you find that there's only one substituent on your cycloalkane, whatever it might be. And so what you're going to do is you're just going to name that substituent, but you're not going to add a number. And so if you guys think about like a cyclic ring, for example, like a stop sign or a square or a pentagon, since it cyclizes, if you only have one substituent, then that substituent is always going to be referred to as since there's only one substituent, that would only be carbon number one. And so since it's always going to be carbon number one if you only have one substituent, then there's really no point for you guys to number that specific carbon. It's kind of redundant. And I'll show you guys what I mean in just a second. Now, if you guys do have two or more substituents, you guys need to add in your carbon number, your locant. And there's two different ways that you guys can see your substituents on a cycloalkane. You guys can have both of your substituents or more be identical. And so if all of your substituents are identical, in other words, if all of them are methyls or all of them are ethyls, then you're just going to number the parent chain such that the sum of the locants or their positions give you the lowest value. And that's what we've been doing for the past few lecture videos. And now if they're different, you're still going to do the same thing. You're going to try to find the sum of the lowest value, but you want to give the priority, the lowest value, to the substituent that is closer to the first letter of the alphabet. So that would be A, okay? So you want to give the lowest value to the substituent that has a letter that starts with a letter that's closest to the beginning of the alphabet. And that's only the scenario if your substituents are different. Okay. And honestly, this isn't something that you guys have not yet come across. We've kind of done this in a few of these in prior lecture videos. Okay. So let's go ahead and start. So let's just say that this is my cycloalkane. So what I want to do is I want to identify the longest chain in my cyclic compound. And so I'm going to go ahead and do this in pink to represent the carbons inside the parent chain. So I have 1, 2, 3, 4, 5, 6. And there's really no other combinations for you to go around this ring. Once again, it's cyclic. And so since I have 6 carbons, then the name of this is going to be cyclo, right? So remember, you have to put the word cyclo if it's a ring. Cyclohexane. Okay, so instead of hexane, or 6-carbon chain, it's going to be cyclic, so it's cyclohexane. All right, so when you guys are numbering the carbons, you want to give, the lowest value to your substituent. Well, if you look at this chain, there's only one substituent. So I'm going to go ahead and highlight this in green. There's only one substituent. And since there's only one substituent, then therefore this is always going to be carbon number 1. Okay. Now, if you only have one substituent, we already know that this is carbon number 1, so it's redundant for us to put this number in our final answer. Okay. And so what we're going to do is we're going to just name this substituent. So this is 1, 2, 3 carbons, and then this line is just going to go to the carbon number 1, so that's the attachment. So we don't want to describe that number, we just want to describe the number of carbons that's on the actual substituent. And so this is going to be 3 carbons, and it's not symmetrical, so it's just propyl. It's not isopropyl or anything like that. Cool. So we're just going to go ahead and put these two pieces together. We're going to describe this first, and then we're going to describe this second. And so the final answer is going to be propyl cyclohexane. And so notice that I did not include the locant, the number that describes where that substituent is attached to on the parent chain. Okay, so I didn't put 1 propyl. The reason why I didn't put 1 propyl is because I only have one substituent on a ring. Okay. And if you only have one substituent on the ring, and since rings are quote unquote symmetrical, I mean there's only one way to represent where that substituent is placed on the parent chain. Okay. And so that's why we're just going to leave it as propyl cyclohexane. All right, so let's go ahead and look at this example. So I want you guys to notice that this example contains 2 substituents. And since there are 2 substituents, and so 1, 2, 3, 4. So we have 4 carbons in our parent chain. And so since this is a cyclic compound, we're going to say cyclo. And then 4 carbons means bute. And then a single bond, if you look at everything in the box or in the square, everything is a single bond, so we're going to say butane. Okay, so cyclobutane. All right, so now that we have the parent, let's go ahead and talk about the substituents and the numbering of this cyclobutane. And so notice I have 2 different substituents. I have a methyl and I have an ethyl. And when you have 2 different substituents on a ring, we want to make sure that the lowest value is given to the substituent in which its first letter is closer to A in the alphabet. In the alphabet. So you go in alphabetical order. Okay. And so therefore E is going to come first before M. M is going to come second. So now that we know that we're going to now that we know that ethyl comes first, we need to figure out a numbering system so that the sum of the values gives me an overall low value for my substituents. And so I'm going to go from, so since ethyl is number 1, I'm going to say that this is carbon 1. So I can go two ways. I can go this way or I can go this way. And so for a ring, I'm going to describe this as clockwise and counterclockwise. All right, so for blue, for rings, I'll go ahead and do clockwise for blue. Okay. And so what if I number it this way? So 1, 2, actually let me do this outside. 1, 2, 3, and then 4. Okay. So I'm going to label this as clockwise. So if I number it clockwise, I have a substituent on carbon 1, and I have a substituent on carbon 4. And so therefore the sum of those substituents, or the sum of those values, is 5. Okay. Now in green, I'm going to do counterclockwise. And so this is not left to right or right to left, this is clockwise, counterclockwise, because now we're talking about something that's cyclic. And so counterclockwise, I'm going to go this way. And so this is going to be 1, 2, 3, and then 4. Okay. And so here in this case, notice that I have a substituent on carbon 1, okay, which is that ethyl group, right? So this guy is on carbon 1. And I have a substituent on carbon 2 if I number it clockwise. Okay. So 1 plus 2 is equal to 3. And so it looks like our green color is favored. So it looks like counterclockwise is favored in this scenario. So finally, green got a little spotlight in terms of numbering. Okay. And so since we're dealing with 2 or more substituents, we have to communicate to the reader what number these substituents are on. Okay. What carbon number these substituents are on. And so it turns out that ethyl is going to be on carbon 1 on this cyclobutane, and methyl is going to be on carbon 2 for this cyclobutane. Okay. So it's a little bit tricky in the way we started. We want to determine, if there are different substituents. You guys need to determine which one you guys are going to name alphabetically, which one is going to be first alphabetically. Okay. And then now that you know that it's the ethyl that's going to be named first, you want to make sure that that's always carbon 1. Okay. All right. So let's put this together. We're going to say 1 ethyl. And then 2 methyl. And then finally, we're going to put in cyclobutane. Okay. And so to make sure that our nomenclature grammar is correct, we're going to go ahead and look at these transitions. And so I have a letter to a number, so that's going to be a dash, and then a letter to a letter. So that's going to tell me that I don't really need to put a dash or a comma. And all I need to do is take this guy and kind of squeeze it in there. And so I have 1 ethyl, 2 methyl cyclobutane. Okay. All right. So let's go ahead and look at another example. Okay. So here we have a cyclic compound, 1, 2, 3. And so the name, the parent name, doesn't really matter how you do it, clockwise or counterclockwise, you'll always end up with 3. It's going to be cyclo. And since there's 3, that's prop. And since they're all single bonds, then that's ane. So cyclopropane. And looking at the structure, notice that cyclopropane only has one substituent. And that substituent is highlighted in this light green color. Okay, so now that we have the substituent identified, notice that there's only one substituent. So that singular substituent on this ring automatically makes it carbon 1. Okay. There's no other substituents on this ring. So wherever this substituent is attached, that's going to be carbon 1. But because we're only working with one substituent, it's redundant for us to say that it is carbon number 1. And so all we're going to do is name the substituent without its carbon number, or the position of the carbon that it's on. And so looking at the structure, I have 1, 2, 3 carbons, and it looks pretty symmetrical right in the middle. So this is probably isopropyl. Okay. So traditionally, again, we're supposed to do like 1 isopropyl. That's what I've taught you guys in previous lecture videos. But for cycloalkanes with only one substituent, you guys do not need to write that 1. It's being redundant because there's only one substituent and it's on the ring. And that makes that carbon where that substituent is located always carbon number 1. And so our final answer is going to be isopropyl cyclopropane. Okay. So there's no number. No carbon number needed. All right. So let's go ahead and look at the next one. So it looks like here we have a square. So I'm going to go ahead and mark that off. I have 4 carbons. And so that's going to give me a cyclobutane as my parent name. So that makes my green highlight. So whatever I highlighted in green, that's going to be my substituent. And so to identify the substituent, that's going to be an ethyl. To identify this substituent, that's going to be a methyl, right? We have 1 carbon versus 2 carbons. And since we have 2 different substituents, we actually do need the number. Okay. So this is a sharp contrast with the previous example where, if you have 1 substituent on a ring, you don't need the number. But here, since we have 2 substituents on a ring, we do need to communicate to the reader what carbon number they are attached to on the parent chain. Okay. And so to do that, we need to think about which one we're going to name first. And so we have E versus M. E comes first, so that's alphabetical. So that's probably the first substituent that we're going to describe. And then the next one is going to be that methyl group. Okay. So we can go ahead and figure out how to number this parent chain. It looks like, since they're both on the same carbon, it's going to be carbon 1. So if you go from like left to right or right to left, it doesn't really matter. because both of your substituents are on the same carbon. They're not found anywhere else. So I can do 2, 3, 4, or I can do 1, then 2, then 3, then 4. Notice that I'm still going to get 1 for both the methyl and the ethyl. Okay. So I'm just going to put 1 ethyl, 1 methyl. And so when I put all of this together, I'm going to go ahead and describe the ethyl first. So this is going to be 1 ethyl dash 1 methyl. Now I'm not putting 1 comma 1 because these are completely two different substituents. Last but not least, cyclobutane. Okay. And that would be the name. All right. So let's go ahead and look at the last problem for this naming cycloalkanes, and we're going to go ahead and review some things using the PowerPoint. So we're not quite done just yet. Almost. All right, so once again, here I see a cyclic ring. So that's going to be cyclopentane. And I know it's cyclopentane because pent means 5. I have 5 carbons. So cyclopentane. And this is the reason why it's very important for you guys to really memorize your prefixes for organic chemistry. Meth is 1, eth is 2, prop is 3, bute is 4, pent is 5, hex is 6, hept with a T is 7, oct is 8, non is 9, dec is 10. Okay. And so everything that I didn't highlight in pink, that's going to be a substituent. Oops. Okay. And so this substituent is going to be an ethyl. This substituent is a methyl. And the substituent is also going to be a methyl. Okay. All right. And so once again, since we are talking about rings, we want to think about which substituent is going to be named first. And that substituent is going to be carbon number 1. So here I have E, M, and an M. So E comes first before M. So therefore this guy, ethyl, should be named first in our final answer. So that means it makes this carbon, carbon 1. So this is something that you must do. You must identify what carbon 1 is on a ring. You can't just arbitrarily say, oh, I think this is carbon 1. Your carbon 1 in a ring has to have a substituent. Okay. And so to determine which substituent gets carbon 1, you have to look at the first letter and arrange them in alphabetical order. So this is carbon 1, and now we have 2 paths. We can go clockwise, or we can go counterclockwise. Okay. So let's go ahead and do counterclockwise since my pen is already in green. And so if that's 1, then this is 2, then this is 3, 4, and 5. And so if I go counterclockwise, I see that I have a substituent on 1. I have a substituent on 3, and I have a substituent on 5. 1, 3, and 5. So if you add all of those up, that's going to give me 9. All right, so let's go ahead and check out clockwise. And so if I do clockwise, and this is 2, 3, 4, and 5. Okay. Oops. Okay. All right, so if I do clockwise, I have a substituent on carbon 1, and then I have a substituent on carbon 2, and then I have a substituent on carbon 4. Now if you add all of that up, that's going to be 7. So it looks like the numbering system is going to be clockwise and not counterclockwise. So I'm going to erase everything that's in green just to kind of clarify my numbering system. Okay. And so therefore, this is going to be carbon 1 based on my current and updated numbering system. This is going to be carbon 2. And last but not least, this is carbon 4. Okay. So the methyl groups are attached to carbon 2, and the other methyl group is attached to carbon 4. So let's go ahead and put everything in order. And so we're going to go ahead and describe the ethyl first. So this is going to be 1 ethyl. And then I have a methyl here, and I have another methyl here. So I'm going to combine them together. So I'm going to get 2, 4 dash dimethyl. Okay. So I have 2 methyl groups. If you have 2 methyl groups, 2 of the same substituents, you want to describe them in just one small item. So you don't want to say 2 methyl dash 4 methyl, just being redundant. And then last but not least, we have cyclopentane. And to make sure that my OChem grammar and nomenclature is correct, this is going from a letter to a number, so I need a dash. And this is going from a letter to a letter, so that doesn't require anything. And I'm just going to go ahead and scoot that guy over. Okay. And so this is going to be my final answer. Okay. All right, so hopefully by going through some of these problems for cycloalkanes, you guys get a feel of how to name them using the IUPAC nomenclature. So the last thing that I want to discuss before we move on to the next one, next topic. So we've gone from like the structure to the name. And so now I need you guys to practice, if you guys haven't done so already, going from the name to the structure. And so we're going to go ahead and go through about 6 examples. All right, so whenever you guys are going from the name to the structure, the first thing that you want to hone in is the parent name, whether or not it's going to be like a straight chain or if it's going to be a cyclic ring. Here in this case, there's no cyclopentane, it's just pentane. So that means I need 1, 2, 3, 4, 4, and 5. Okay. Now if you guys started up, you guys can do that as well. So in other words, if you go up 1, and then 2, and then 3, 4, 5, sorry. So if you draw your structure like this, that's absolutely okay. Okay, they're equivalent. So now that you've drawn your parent structure, you guys want to add in your substituent. So notice that there's two methyl groups, so it's dimethyl, and they're both on the third carbon. And so whenever you're going from your name to the structure, you can number your carbons any which way. Just make sure you guys are consistent, either left to right or right to left. And so for me, I'm just going to go ahead and number it from left to right. So 1, 2, 3, 4, and 5. And so it's telling me that on the third position, or the third carbon, I have two methyl groups. So I'm just going to go ahead and put in a line and another line, and those are my dimethyls. Okay. So remember that this end of the line represents one carbon. And remember that for organic chemistry, the skeletal structure, all of the hydrogens are being ignored. Okay. So if I were to add those hydrogens in, it would look something like this. Okay. But we don't write that into our skeletal structure. So we're just going to go ahead and leave this as our final answer. Okay. All right, so for the next one, we have trimethyl. Oh, what's going on? So we have 2,3,5-trimethylhexane. So hexane, we have 6 carbons. So we have 1, 2, 3, 4, 5, 5, and 6. Okay. And so here, now that we have our hexane, we have 3 methyl groups, one at 2, one at 3, and one at 5. And so I'm just going to arbitrarily number this as 1, 2, 3, 4, 5, and 6. And so I have a methyl group on 2. So I'm just going to go ahead and draw a methyl group going down. You can draw it up. That's okay. Same thing. And then I have another one that's on 3. So I'm going to go ahead and draw it down just because I don't want it to interfere with the number 3 that I wrote. And then last but not least, I have 5. And so this would be the structure for this compound. Now, once again, just to reiterate the point, if you guys drew your structures in this manner, then that's equivalent as well. Okay, I just need to see a methyl group on 2, 3, and 5. It doesn't matter if it's up or down. Okay, so I'm going to go ahead and now let's go ahead and do this one. So let's do this one very quickly. So octane, so that means 8 carbons. So you have 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So I have an ethyl on the third position. So let's just say this is carbon 3. I have 1 and then 2. Okay. So ethyl is 2 carbons. So I have 1, 2 carbons. And on the second carbon of the parent chain octane, I have a methyl. And on the fifth, so this is 1, 2, 3, 4, 5, I have another methyl. Okay. So this would be my skeletal structure for this specific compound. Oops. Okay. All right. So we're going to go ahead and do these 3 very quickly. So 1-bromo-2-chloroethane. Eth means 2 carbons. And so I just simply have this as my parent structure. Now on the first carbon, I have a bromine. So I can just go ahead and put in bromine over here. on the second carbon, I have a chlorine. And so if I want, I can put that chlorine up or down or whatever. I'll just go ahead and put it down for now. So that way you guys can see the actual carbon, that corner. And that would be it. And so the next one is going to be ethyl cyclopentane. So cyclopentane means that we have a ring and there's 5 carbons within that ring. So think about a pentagon. Okay. Doesn't have to be perfect, that's okay. But when you guys are looking at the name, notice that there's no number in front of ethyl. And eth means 2 carbons, so I have a 2 carbon substituent. And so since there's no number, you can just place that ethyl wherever you want, just as long as there's 2 carbons. And by placing it, for example, here, that would automatically make this carbon carbon number 1. Okay. So this is the reason why for a mono-substituted cyclic ring, you do not put a number in the name because there's only one item, and it automatically gets, it's implied that that's carbon number 1. All right, so the last structure here, we have, we've done a lot of chains. So let's just say that this is cycloheptane. I don't know how this is actually going to work, but let's just say that it's cycloheptane for now. Actually, no, I can't, because then I would have changed some other stuff. So forget it. It's okay. So let's go ahead and work with this. So this is just a regular chain. Heptane, hept means 7 carbons. So I have 1, 2, 3, 4, 5, 6, and 7. So that's done. Working from left to right, I have 2 chloro, so on the second carbon. So from right to left, so I'm going to make this guy carbon 2. This is going to be chlorine. And then it looks like I have another 2, but this time it's a methyl group. And so I'm going to go ahead and put in another methyl group. I'm just going to stick it out there. Okay. So remember, a methyl is just that line with only one endpoint. Okay. So I did this, I did this. Now on the third carbon, I have another methyl group. So I'm going to go ahead and put it this way. And then on the 5th carbon, I have another methyl group. So this is 1, 2, 3, 4, 5. So I'm going to put another methyl group here. And then it looks like on the 4th carbon, I have a propyl group. Okay. And so I have 1, 2, and 3. So notice that my propyl, it doesn't say isopropyl. So that means that I don't really have a symmetrical compound. I just have 3 carbons, which is represented by those dots. Should have zoomed in. All right, so let me just redraw that. So this is once again 1, 2, 3. And that's going to be my 4-propyl. Right? So hopefully that helps you guys understand how to translate the name into a skeletal structure. Okay. All right, so the next topic, we're going to be talking about alkenes and alkynes. And so I'll go ahead and stop this current lecture video. And in the next lecture video, we're going to talk about alkenes and alkynes.